Executive Director of OpenPOWER Foundation.
Thanks very much. Welcome to day 2 of the OpenPOWER North American Summit. It's a great pleasure to invite you, to welcome you here this morning. We had a great set of talks, keynotes yesterday to kind of kick things off, and we've got even more wonderfulness to come. I'd like to thank our sponsors. These events, of course, don't operate in a vacuum, so we're very grateful for the support of our premium sponsors, IBM, Samsung, and Yadro. Our strategic partners or sponsors, Bitware, Inspire Power Systems, Raptor Computing Systems, and Smart DV. And our advocate sponsors, Everspin Technologies, H3 Platform, Mellanox, the OpenCAPI Consortium, Smart Modular Technology, and Wistron. One person that's not up there on the slide that we did also want to acknowledge is the Linux Foundation, who have done so much of the logistics and really enabled this event to happen. So we're particularly grateful for all their hard work as well. It's been a great team. If you'll indulge me, a little bit of a straw poll. I'm kind of curious how many of you, this is your first OpenPOWER Summit? Okay, that's cool. So I've got to say, you've actually chosen a bit of a cracker. It's not your first one. You've chosen a cracker of an event to make your first show. This kind of, for me, it's kind of like being a kid at Christmas, right? There's sort of, you see the present under the tree, it's been there all this time, there's all this stuff sort of leading up to it, and I've sort of been fortunate enough to know much of the detail of the announcements that come out. But you can't tell anyone about it. And it's like, come on, really? So it's kind of like Christmas morning. We're finally able to take the wraps off, I think, what will prove to be some of the most significant and impressive announcements for the OpenPOWER Foundation, and indeed the whole Open Technical Commons. Pretty much going to leave it there. We're going to run a video just to set some context. Enjoy the rest of the day. Thanks for your time this morning.
When the biggest names in technology decided to join forces, they had one goal: to explore the power of new possibilities. Building on the foundation of the IBM Power architecture, they set out to broaden the reach of power across the industry. The OpenPOWER Foundation has facilitated innovation and choice through open collaboration with over 350 members, sharing technology and methodologies, all leveraging one of the most mature, high-performance processor architectures and a first-class open-source ecosystem. Open development on IBM Power architecture has enabled unprecedented customization across the full software and hardware stack, from applications to operating system down to firmware, leading to over 100 software and hardware innovations in the last 4 years alone. Everything from entry-level secure developer workstations, AI, machine and deep learning and high-performance computing servers, to components like high-speed server and GPU interconnects, edge devices, and hyperscaler nodes. End-to-end breakthroughs in high-performance computing, from affordable servers that make the power of HPC more accessible than ever, to the creation of the 2 smartest, fastest, and most powerful supercomputers in the world, both with the compute power to solve some of the world's most challenging problems, using the Power architecture and cutting-edge partner technologies. OpenPOWER Foundation's mission of open innovation is just getting started, continuing to drive that innovation and help partners achieve unprecedented success. When the foremost leaders in technology team up to revolutionize the industry, the momentum is unstoppable, and your future is wide open.
Please welcome to the stage Ken King, General Manager, OpenPOWER Alliances at IBM.
Thank you, and good morning. Hugh's comments kind of cracked me up a little bit about Christmas and opening presents. Feels a little bit like Kris Kringle here on stage, even though my team probably chuckles whenever they ask me for money. It's more like Scrooge. But no, I'm really excited. I really enjoy coming to these events and every year, and here in China, and we do them in Europe as well, and engaging in and experiencing all this new innovation and capabilities that come out through this community. And it's really a lot of fun to watch, collaborate, and experience it. Today is more exciting for me because I get to deliver some of it. And I think what some of the stuff we're going to talk about today and what I'm going to be providing to you, I think is game-changing for the open community. And so let's get started. Let's get into it. So first, just a reminder, I think everybody has seen this chart before, right? You guys all know why we started OpenPOWER. We all saw the fact that Moore's law was dead or declining, and the You weren't seeing any longer the 2x performance every 2 years or 18 months, and the need to be able to accelerate up and down the stack. Accelerators, software, networking, connectivity, storage, et cetera. And the ability to be able to do that is becoming even more important as we move forward. When you look at the explosion of data, the algorithms and artificial intelligence, and their need to be able to process that more effectively. We're seeing custom hyperscalers and others that are hiring their own chip designers, developing their own accelerators and their own memory controllers and their own capabilities in that stack to advance and accelerate the performance of these systems that are necessary to drive the workloads of today and especially of tomorrow. And that's only done effectively through open innovation. So this is what we've been doing with OpenPOWER for the last 5 years has been important towards that objective. But we needed to take it to the next step. And we see transition happening in the industry that justifies taking it to the next step. We're seeing this innovation happening in different ways with open hardware. We're seeing different players, different new open ISA communities come into play. And the effect that they're having on the industry is demonstrating the need to continue to drive an open type of computing environment and governance structure to drive that innovation. And we're taking that to the next step with Power. But with that said, let me just remind everybody, we have made significant progress to date. With the 350 plus members we have in the foundation, we've had hundreds of innovations. We have over 40 different types of server solutions that have come out in the market, more than 20 different vendors that have delivered open solutions in the community, along with a lot of different work being done at every different layer of that stack. And we've delivered, we, the community, have delivered that all the way down from low-end workstations like Raptor has delivered, all the way up to the top supercomputers in the world. The #1 and #2 supercomputers at Oak Ridge and Lawrence Livermore. That was done through a community of innovation, many different players. There were over 20 involved in that, people like Mellanox and NVIDIA and Red Hat, Samsung, Seagate, Supermicro. I can go on and on. Many different players that were involved in the delivery of that through an open ecosystem. So this initiative, this foundation, this community has been very effective. But as we see the industry shifting even further and quicker to open hardware environments, we know as a leader, having an enterprise-scale instruction set architecture with high levels of security and high levels of performance, we can provide that leadership to the industry with that open hardware, and we're going to do that. So if you look at where the future of computing goes, we are looking at purpose-built processors, right? We are looking at a different way to innovate in an open community versus your standard traditional ways to deliver hardware. Okay? We're looking at heterogeneous computing being critical. And as I said, innovation up and down the stack is required to do that. The only way to effectively do that as a community is through an open environment. IBM has been leading that ever since the beginning of the open thrust in the community. 1999, I think it was, we spent $1 billion. We committed $1 billion to Linux before anybody else was even serious about Linux. And this is only a subset of the things we've done. You're talking about the Eclipse community, developing and creating, jointly with the community, an open developer toolkit environment for being able to create software with Eclipse. We were critical contributors to Kubernetes, to Docker, to OpenStack, as far as helping drive those communities forward. And of course, working closely with Red Hat on the Linux kernel. And then, of course, the announcement with Red Hat. All those initiatives on the software side, IBM has been a leader from the beginning in driving the advancement of those critical software capabilities in an open ecosystem type of approach. We started doing that on the hardware side in 2013 with OpenPOWER, and then in 2016 with OpenCAPI, and driving a much more open approach to coherent accelerator and memory interface standards. And now we're taking those things to the next level. So I'm going to talk today about what we're calling our open chip design environment. We have a number of different things that we're announcing today around this next step with OpenPOWER and the open community and OpenCAPI. First and foremost, we're taking the Power instruction set architecture. Okay? We are licensing it to the OpenPOWER Foundation so that anyone can implement on top of it royalty-free with patent rights. And that's going to be done through the community. Okay? We are going to be doing it in an open governance model. That open governance model is going to be done through an open governance work group in the OpenPOWER Foundation, where it's a majority vote to enable enhancements, extensions, and implementations or new instruction set architecture capabilities that are added to the instruction set architecture. Very significant, that announcement, to do it through an open governance model through the community. We are taking OpenCAPI and OMI, the Open Memory Interface, and we are contributing that to the community through the OpenCAPI Consortium. That RTL, those reference designs, will now be available to the community. It will be contributed. It will now be part of the community versus IBM controlled. And we are hoping over time, the objective is not just to get those to be more driven as industry standards, but to drive convergence with other standards like CXL. And we've gotten a lot of support with early discussions with a number of members of the community for that convergence approach. Very important, very powerful members who we think will be catalysts in helping us drive that convergence. Also, under the OpenPOWER ISA contribution, you'll hear more from Anton in a couple, I think 2 or 3 presentations after mine, that we are putting a soft core out there. We're contributing a soft core that's going to make it easier for people to be able to do implementations on top of the ISA, leveraging that soft core as a tool, as a baseline that is now contributed to the community. And then last but not least, as a demonstration of the importance of us putting this into open governance principles, the OpenPOWER Foundation is going to be moving as an entity to be part of the Linux Foundation. And it will now be part of the Linux Foundation. It will still be an entity. It will have its own board, its own decision-making, but as an entity of the Linux Foundation. So this doesn't change anything here with this community. This community is still just as critical. But we're making a statement to the industry that it's going to be part of what I would consider the Linux Foundation one of the leading players in the market, in the world, around open governance structures and principles. Okay? This is the announcement. We consider this game-changing. We consider this big. Before we made this, we have reviewed this with lots of different industry players, and we've gotten lots of endorsement. Lots of excitement, actually, out there in the industry. You can see the names on the list. We've gotten support and endorsement and excitement from some of the leading open operating system vendors in the world, some of the leading server vendors in the world, leading accelerator vendors, leading interconnect vendors, leading hyperscalers in the world, some major research institutions in the world. And, we didn't go to everybody out there. We went to players we thought were important. And I don't remember a single player not saying to us that, wow, this is something. This is going to make a difference in the industry. So we're really excited about what we will be doing once now we execute on this announcement. And what really I enjoy about this is, as I said before, IBM has demonstrated our ability to be leaders in the open community since the beginning. IBM is now the only processor vendor in the world that is open from the lowest levels of the hardware, the instruction set architecture and the firmware, all the way up through the software, the server software stack. And Power is the only architecture that is open all the way from the lowest levels of the hardware up through the server software stack. That's a statement of our commitment to this. And if anybody, I shouldn't even say this, but I will. If anybody says, well, you're opening it up and you're moving it under this, and is there any decommitment from IBM? No, this is a further commitment from us. We're out Power 10 Power, 11 Power, 12. Our roadmap is committed for the future, and we're accelerating that. But in order for the industry to get the benefits that they really should be getting out of the Power architecture, we want to drive more innovation in the ecosystem, not just IBM, but in the entire ecosystem. And we started doing that with the foundation pretty effectively. We want to go to the next level of big with that, and that's what this announcement's all about. So let me close it by bringing up Mike Dolan, who is the the VP of Strategic Programs for the Linux Foundation, just to give us a couple of minutes, if you could take us through why you think this announcement is important, both for the Linux Foundation as well as for the open source community.
Yeah, I think this is an exciting announcement for us. We've been working with the OpenPOWER Foundation on the side, for a long time, so we have a good working relationship. But as we look to where things are going in the industry, you're starting to see an incremental evolution from a lot of the cloud infrastructure being open source, some of the industry applications being open source. You see a number of industries gravitating towards an open development model. And while that started in open source software, and Linux was a perennial example of what you can succeed with when you get to an open infrastructure, you're looking at now evolutions of that into open hardware. OpenPOWER is one example. CHIPS Alliance is another example of where organizations are saying, it was great that we were able to do that for source code, but can we do that for hardware? Can we do that for the instruction set architecture, the firmware, the verification and testing tooling and things around it? Can we get to a better place if we have a core plumbing that we can build on? And that's where it's not about giving away all of the intellectual property. It's about putting a core plumbing set out there that everybody can build upon and be able to build their own value-add solutions and additional things that scratch their itches or address their use cases. That maybe it's not something the entire world needs, but they're allowed to adapt and evolve the architecture to where they need to go. And this is something where I think OpenPOWER is at the forefront of that on the hardware side of things. Certainly we're seeing collaborations even beyond just the hardware to open data. IBM was actually also a significant contributor to community data license agreements and things where we're working on open data, we're working on open software, we have open specifications and hardware or open specification standards that we've been working on. So across the various technical areas where people collaborate, we're starting to see more and more open collaboration. And I think that that's a powerful thing. If you look at a lot of these examples, it's not just Linux anymore. We now have hundreds of examples of software, specifications, hardware designs that you're all dependent upon, whether you know it or not, but you're building value-added solutions and other capabilities around it. And because you have that base layer that is open and shared, you're able to do that with a much faster time to market. You're able to do it in a much more compatible, interoperable way so that things start to work together at a better level. And so I think it's exciting. I think we've been working together for a while. So the partnership with the Linux Foundation, I think, is an evolution of where we were at. But I look forward to working with you and seeing where we can take this next, because I do think there's a lot more. This is, I think, step one for us. There's a lot of steps to come in the future, and we're certainly excited to see where it can go.
Thank you, Mike. Appreciate it. All right, folks. Thank you, Mike. Now that the presents are unwrapped from under the tree, I hope you guys are as excited as we are, and we really look forward. Now the announcement's out. Now the hard work is going forward, and we look forward to working with everybody on that. Thank you.
Please welcome to the stage Erin Sullivan, Director of Hardware Engineering at Facebook.
Good morning. So what's Facebook doing here? I'll answer that by the time we get to the end of this message. But let's start with this. This is really about, in our perspective, just an extension of a big industry open source push. And Facebook has been part of this with OCP. Facebook runs almost entirely on Linux. Almost everything we do starts with an open first philosophy. And it's been a long journey in our industry to get from where we started in open hardware, arguably I would say, in 2010, 2011, to where we are today. And we still have some distance to go to get the same kind of richness and developer capability and other things that we have in open source software. But we're well on our way, and this is a big step, and that's why I'm here. Just a little bit of a story. I think my whole career, in some sense, has been punctuated by watching open source approaches, open source software come along and kind of slowly just displace whatever else is there and make its space in our industry. And I have watched this in spite of what looks like just chaos and all kinds of other things that come with an open source movement. I have watched beautiful pieces of technology with phenomenal engineering teams kind of just slowly adapt, or in some cases, if they fought it, which is not the case here, get pushed aside by this mob of crazy engineers and revolutionaries and so forth. And, you know, in the earlier part of my career, it never made sense to me why this kept happening. I've stopped trying to make sense of why it happens. It just happens. That's pretty much the story. So what I want to do with the rest of my time up here with you is talk about how that story works and share some wisdom that I've developed in the process of watching this same cycle play out in open hardware a few times over. I'm up here with Facebook, but I was part of what were the early days of and the foundations of OpenPOWER with a different company a few years ago. And so I can tell you, having been on the inside there, the track record is strong, and the setting and the foundations are good for the story that I want to tell to have a very good ending. So the question is, if you look at all these stories of open source communities and how they start and how they end and all the rest of that, you're probably best to think about our situation here as a group that's interested in this as one story here that always starts with the question, why does open source happen? And to my point of view, open source tends to start from some background setting. It tends to start from an environment where we have a very rich set of resources, all stacked in silos. We have siloed IP. We have siloed software. We have siloed engineering teams, and we have many of them. My silo, your silo, their silo, whoever it is. And for some period of time, that suffices to meet all the needs of anybody who's drawing on the resources in that silo, and it's probably the best way to do it. Keeps groups of people tight, keeps them working closely together, keeps the chaos down, keeps them focused. But over time, we start to have problems with those silos, and our end users and our developers and others start saying, I'm not getting enough out of this. I'm not getting what I want. I don't have enough voice. I don't have anything else. And that's when things can start to get messy. Because most of the people that are in here that are the biggest catalyst for change, they're not the whole population, but the biggest catalyst for change, they're not always known for being the sort that are really thinking things through. And if you develop in a chip, I think almost anybody would say the most important thing is that you really thought things through before you built it and the whole ecosystem. Most of those end users aren't as concerned about all of the particulars of the technology that needs to change. They're more concerned and more motivated by the fact that at some point along the line, what went into that silo, in their perspective, the value of it has become compressed. It's not that it doesn't have value. It's that it's not to them what it once was. So they're motivated by the fact that they want more out of these silos and what's in them than what they had before. And they may also feel like change is not happening fast enough or broadly enough or in the direction that they want. And in my perspective and experience, most of this is born out of the fact that we have too many groups of individuals sitting in silos with not enough differentiation between those silos. And what we do best to do is break those walls down and get most of those resources that were once stacked in a silo doing similar things working together for something bigger and better. And in our industry today, the sources of challenge for innovation are not about money. And they are not, at least not about lack of money or lack of investment. They are about fundamental problems with the way that we construct systems and the materials we use to build them and the protocols we designed them to run with and the fabrics we connect them with and so forth. And these are some of our hardest problems. So across all of these spectrums, we need more creativity, more innovation, and a broader base of adoption on some common silos than what we have today if we really want them to take off. Today we have stories in our industry you can look back on of many competing buses, of many competing firmware stacks, of many of these other things. And today what we really need is less competition between things that are the same and more fundamental improvement and innovation that moves beyond all of that. Now, if you were around when we had candy bar cell phones, you remember how much money it cost and how much time it took to build an infrastructure of I can use my phone anywhere. You remember maybe how hard that was if you were ever anywhere near telecommunications. This does not come quickly, and it was hard fought, and there was a lot of value to it. But I think most of us know, as valuable as that was, our world is way different because we moved beyond what was a candy bar phone into something else. Think about, just for a minute, what would be different in our economy, in your day-to-day life, and everything else if our innovation around mobile phones at some point, for as awesome as they were, just stopped at that last candy bar phone. Okay, and then think about what happened when a few organizations came along and rethought what was going to go into that and decided to provide an engineering platform for co-developers, for consumers, for anybody else, so that they could really expand what was possible in that space and start solving more of their own problems. This took fundamental innovation in the system, a really good software stack, and some great community management. But you could say that, our world has changed dramatically just because of that little piece of glass and metal and silicon in your pocket sort of being revamped and shared. So maybe that's a compelling reason to say we should let more people get involved here, like Ken's announcement, like everything that we're seeing with OpenPOWER. But a lot of people ask a question, if I share this with everybody and I tell them all we're going to open governance and everything else, and I have all these dreamers, so forth out there, isn't this going to ruin what I built? I mean, there's a lot of revolutions out there that happen in the world that, get messy, they don't end well. Okay, let's not pretend that doesn't happen. Okay, let's not pretend that periodically a revolution turns into something like this. It's a legitimate question. But I also don't think that for the most part in our industry, when we hit these conditions, we have any reasonable, rational choice but to actually take that next big step and adapt, right? Because which thing generates economic value that's going to get everybody moving forward and keep this segment of our industry viable and keep all of the investment and innovation there? I think the answer is obvious, even if it seems strange and risky sometimes. And so if you're sold on that and you say, this is great, this is the outcome I want, and it all sounds nice and all the rest of that, but I'm also aware of the risk. If I'm moving along in that direction, how do I know whether or not I'm headed down the road towards something that's really good, or I'm headed down the road towards some kind of disaster or mess, and I'm going to regret this later? Okay, I think in open source software we understand that pretty well, and I think in open source hardware we're still figuring it out. So let's talk for a few minutes about what's different fundamentally between doing open source hardware as a big community and software. And there's a lot of stuff I'm not going to touch on here, but here I think is what's most important when you're working in this space. Almost never do you get to have a clean sheet when you're doing open source hardware. Almost always you're coming from some type of legacy. It's already been implemented, it's already been documented, it already has a community of engineers, it already has really popular ways of being used, and all of those things have a lot of inertia. And if you're going to reinvent something, it's hard to start in that space from scratch and get anywhere quickly or at all. So the best thing to do is to actually open up what you already have and share it with everybody. But that presents some difficulty, because what everybody wants to do is take your big, beautiful vehicle and strip it down to its parts and modify little bits and pieces here and there, and in the end, what you want is an outcome. You want a vehicle that somebody can actually drive despite whatever's going on with the modifications. And letting people in to investigate it and to modify it and then to validate it and ship it and all the rest of that, it's costly, it consumes a lot of time and attention, and it's risky. So it's important in this particular case that we have all of the necessary tools, and Mike used the word plumbing. I'm going to use that again. Plumbing in order for a movement like this to thrive. And one of the hardest parts about open source hardware development today is that there is not nearly the kind of plumbing we have relative to open source software. If you worked in open source software in the middle 90s, you might remember people pushed patches to like basically Usenet groups. People were storing code on what is less sophisticated than your average Reddit thread is today. And somehow you're supposed to make this all work, and it's supposed to compile nicely. And today, I think it's almost impossible to imagine that kernels were born in that space. All this software that was Linux was born in that space, because when you look at the tool set they have now, it's so powerful by comparison. I mean, it just makes everything easy to get in and develop and test and fork and make all the changes and all the rest of that. So it's primed to let everybody's creativity run amok and still get a pretty good outcome. And in open source hardware, we actually need to install more of that plumbing. And what I think is one of the most special parts about this announcement is it brings a lot of potential and a lot of initial value to that plumbing question. Ask yourself, what development tools do we have out there that are open today to work in this space? Not enough, but more with this. Think about the difference between when you're writing open source code and you've got compilers or JITs or anything else like that, about how agile that is. And you need the same thing in your EDA and your other toolkits to come along. And you probably want that with really good reference implementation so people have a place to start from to get moving faster. This I don't think we've solved yet, but it's great to just send your source in, get it compiled, and test and ship it. And we don't have anything like that in a fab today. We don't have anything like that in validation. But things like this will get us much closer sooner than on the course we were on, well, Ken, I don't know when you started this, but let's say yesterday. Or a month ago, or a year ago. And then finally, there has to be a market space that develops here that's a little bit more complicated than downloads. It's not that a lot of this probably won't work in the same sense of source code and data that is interchangeable and you can use. But in the end, shipping a chip requires shipping product. Shipping open product requires an ecosystem that can support open product, and that too takes some time to develop. But there's the right sort of fundamental basis here for all of these things to happen. And then the last part is licensing. I don't think our industry has fully cracked open source hardware licensing yet, and patent protection and everything else. But again, I think today this is a huge step in the right direction for our whole industry. If you were around when Linux was first getting hot and people had a lot of questions about it, the biggest concern was, is this legally viable? Am I going to get myself in trouble if I adopt and use this? Am I going to get sued? But some things happen in that space. And part of what had them ending well were some really big organizations with really rich patent portfolios deciding to step in and back that movement and make sure it was safe for everybody else that wanted to innovate and take some risk there. So this group is to be commended for helping us move along in that direction. I think there's more work to do. So in summary, you want a vehicle to move this forward and move it quickly, you need all of these things in the truck. And I think basically what's been announced here is a really big step forward and something very substantive for all of these things in the truck. So I want to switch gears and talk about one more thing. I'm going to play a video for you for a moment. I think this is a great metaphor for how open source movements come along when you start from something that had a proprietary legacy and is moving out into the open. I want you to pay attention to how you feel while you watch this. Okay. Basically, we have lots of things out there in the world that go through fundamental change from one thing into something else entirely. We watch this happen in nature. It's not a surprise. But sometimes when it's happening right in front of us, in the moment it's happening, there are a few moments that look a little grotesque. It's a little uncomfortable. It's a little like, ugh. You know, I understand how this happens in the end, but I'm watching this go on. I'm in the middle of it. I'm not quite sure it's headed the right way. There's a little uncertainty, right? I mean, that butterfly could be dead just now, or it just pops out and you have something new and beautiful there. And what I'd like you to take away is we've had this happen often enough in open source that this is probably the most likely outcome here. But it's not going to take away the mystery and kind of the weird moments for anybody that's along for this ride. You don't get away from that. That's actually part of what makes it exciting. If it were a certainty, most of us wouldn't be here. It would be boring. You wouldn't be working on it. So this magnitudinal shift we're talking about here is about getting onto that new platform and kind of reinventing something that we already think we know into something else entirely that solves all kinds of new problems. It also needs to end in kind of a boring way. Okay? We need to get as quickly as possible in this space from all this excitement and all this possibility to I can buy this anywhere I want it, I can use it any way I want it, I can talk about it like it's every day and it's routine. There's a lot of commerce and interaction around it. That should be the end goal, right? That should govern a lot of how we think together working in these communities. Yes, we want the most exceptional engineering and the most fascinating stuff, but is this going to get us to a good market? Is this going to get us to, this is just normal? Is it going to get us to boring, but super useful and reliable in some sense in that different world? So I think those are the governing principles. Just some parting advice here based on what I've experienced working in other open source communities. The first thing is, it's forming a new thing here, but it's really easy for this to turn into another silo. There are open source movements that compete with each other. There are open source movements that look at other movements that aren't as open or are closed and say, I don't want anything to do with you, right? And we end up with new silos. And that happens for some good reasons, but it's really way, way better if we all put some energy into making sure that we're doing our best to keep everybody out of the silo, even if you got to pull on them a little bit. Even if as a group we need to exert some pressure on each other, stay out of the silos. Make sure that what we're doing here will integrate with a larger developer community, because the power of open source is in just, for practical purposes, an infinite resource pool of engineers that is happy to be in your space. They're happy to wander wherever they want to go. They don't feel restricted. At Facebook, we have this expression that's been used for years. This journey is 1% finished. And it doesn't matter how many years you've been at Facebook or what you've accomplished or how far you've come. You always seem to end with this message of journey 1% finished. So if you're building a new data platform and you've been doing it for years, and you're making all of these massive improvements, and you're sharing it, and you're growing this huge community, you keep coming back every year and saying, 1% finished. For a little while it confused me. Why do we keep saying that? Why don't we say 5% finished? 20, 50. And I think basically the metaphor is this. You've got to remember that for most of these things, even with all the progress you've already made, there's still a big, open, very interesting future in front of us with a lot of potential. And it's easy to start thinking about getting to the end as if when I get there, I'll just be done. And that kind of causes us to undercut the total potential we can unlock. Okay, so I got into this industry in my career just as we were stopping a lot of really fundamental innovation in computer systems and computer architecture, and really focusing on just incremental version improvement. Don't change things too much. Make sure the system is stable, the architecture is stable, the design principles are stable. And this ran from the core of the systems through our firmware, our compilers, the software we wrote, everything else. I came into the industry around the birth of Java. Nobody wanted to pay attention to the hardware anymore. They just wanted software productivity. Now, I think it's pretty cool to look further back from that when we had all of these strange systems in our industry, some of which were alien, and see all of this fundamental innovation going on, because I could see where the world had come from to get us where we are today. And I kind of like to imagine we get in a time machine and move forward a few years from now. And if you're a part of this and you're working hard on it, this gives you a chance to be one of those individuals to say, I was part of something that presented one of those magnitudinal shifts in our industry. It was once this way, and then a whole bunch of us got together and did something that seemed a little crazy, and we made it into something else entirely. And that's part of the legacy of what you get to say you contributed and you were a part of for somebody else to take from there. So for me, this is probably some significant step of ushering in this new era in our industry. And it's not a really big crowd. It never is. These stories they tell, there's never millions of people. It's usually a relatively small room. It's usually a fairly well-convicted set of people and some open questions. And then you work on it and something else entirely new comes out of it. So I'm really excited to be a part of this today, to share in this announcement, and I see really good things coming forward. And I think over the next few presentations, you're going to see some awesome stuff that shows this is already well underway, even beyond what you've seen so far. Thank you.
Please welcome to the stage Anton Blanchard, Distinguished Engineer at IBM.
So this all started with a simple question for us. Now you've heard the announcement from Ken. Inside IBM, we were quite excited by it. But the question to us was, what else could we bring? It's great to come with an announcement, but can we do anything tangible? Could we perhaps simulate a simple power ISA core? Could we synthesize something on an FPGA even? So a couple months ago, we took that idea away and thought about it. Now, firstly, I'd like to point out a bit of background about myself. I'm predominantly a software person. I work with hardware people. But the last line of VHDL I wrote was at college. I wrote a counter. It probably didn't count. I've never had to design any significant hardware. And we only had a couple months to make this happen. Yeah. Would you trust this man to build hardware? I certainly would not. So what we can announce today is something very simple. It's a first step in a journey. We call it microwatt. It's a tiny power core. It's OpenPOWER ISA scalar fixed point subset compliant. It's written in VHDL 2008. It uses an open source toolkit for simulation called GHDL. It uses the Xilinx Vivado toolset for when we want to do FPGA synthesis, and it's not yet available, but it will be shortly available up on GitHub. Very simple by CPU standards. It's single issue, in order. The aim is to be very simple, and we reuse other open hardware components where it makes sense. There was no sense for us to build a UART, for example, so we just pulled it in from the open hardware world. Classic RISC pipeline. We had to stretch it a bit for timing, but I mean, this is textbook what anyone would probably do at college if they'd done hardware, which I hadn't. So we had the makings of a core. What are we going to do next? Well, we've got to run something on it. So why not run MicroPython? Anyone heard of MicroPython before? Yes? No? Good few people. Heard of Python? I hope so. So basically, it's just a very simple embedded interpreter. And the idea here is it's self-contained, it's simple, but it's actually quite useful. And it's used in a lot of places. You'll see it all over the place in the microcontroller and low-end kind of embedded world. So we took MicroPython, and one of the team back home, Michael Newling, ported it to our microwatt core. One of the good things we found was it didn't require any generic changes. Basically, all we had to do was add platform code, which is what you always have to do when you add a new platform to MicroPython, things like the console and stuff like that. And with that, we had basically the makings of a very simple OpenPOWER ISA core. So what we're seeing here is we're just going in to build MicroPython, and it builds and it produces an image. It's basically a RAM image that we can load in. So now we jump into microwatt and we build it. And once we build it, then we basically, all we have to do is link in the RAM image that we built from Python and we run it. And basically at that stage, we are interacting with a simulated power core. So this is the compiled VHDL and basically executing instructions as you would on real hardware. It's a little slow, obviously, and hopefully we can add up, and we can. Fantastic. So that was the first step. We've simulated something. What can we do next? Well, next step was enter. I had an FPGA board lying around, and it was a fairly old one. It's a Xilinx Artix FPGA and a little development board from, I think, Digilent. And the question was, can we take that VHDL and can we make it work on top of the FPGA? And turns out we can. So this is just a quick demo of Vivado. We're basically loading up the built VHDL, loading onto the FPGA, just over the USB. And if we flip across after this point, we get the MicroPython shell. So this is actually running MicroPython now on a FPGA. And the first thing you always want to do is run a hello world. And that runs. Great. We'll also try something a little more stressful than that because that doesn't really prove too much. So we'll just run a quick Fibonacci sequence. So we'll just copy and paste that and then copy it back into the Python interpreter. And it runs. So we've got something now that runs on an FPGA. And so we thought that was pretty cool. That's great. What next? And at that point, well, firstly, I would like to point out, I'm sure you're thinking at the moment, yeah, nice demo, but are there any smoke and mirrors? And I want to tell you today there are absolutely no smoke and mirrors. Okay, there are some. So we'll run through that next. There's a few limitations, as with all good demos. We don't have any hardware divide instructions at the moment. We just ran out of time. What we're able to do is basically pull it out of the tool chain temporarily. No reason for that. We can pull in a very simple divider from other open hardware out there. That shouldn't be a problem at all. We're still working on caches and bypassing. As I said, it's very simple, but that should be easy to use. Again, we can pick up some caches from some of the open hardware implementations as well. It's not optimized, it's a proof of concept, but it does work. So at this point, our friends at Xilinx came along and said, can you do anything with one of our great Alveo acceleration cards? So we thought, yeah, we'll give it a go. So they sent it out a couple of weeks ago, and we threw it on, and we managed to make it work. Now, one thing I will point out, if you've used FPGAs before, this is like a chip real estate. Our little core is that little bit of blue. So we thought, we're not even using this FPGA. What can we do next? And so we thought, obviously, how many of our cores can we fit on an FPGA? So at this point, I'll open up for suggestions. How many do you think we managed to fit? 200? 200? I admire your optimism, Hugh. You're wrong. And I've brought koalas, so have a koala. Any other takers? 40. Who said 40? Wow, you've been prompted. You're correct. Can you catch? In fact, yes, we fit 40 of them on this FPGA. Actually 41, because we had the main CPU. So what are we going to do with this new power that we've found? Well, what are we going to do? Let's think of something interesting. Well, I mean, as I said, these are very simple. They're not coherent. They run just the power ISA fixed point subset. What are we going to run with it? Well, I thought, let's run an accelerator. We'll have 40 accelerators doing something really useful. And I thought, what do I spend most of my time doing every day? And then I thought about it for a while, and I thought, gosh, it seems like each day a new language comes out, and I have to investigate it and look at it. I seem to be writing hello world applications all the damn time. So I thought, why don't I write a hello world accelerator? So I've got 40 OpenPOWER cores all running an accelerator. Its job in life is to print hello world over my hello world bus. The real reason was I only had a day to come up with this, so I couldn't think of anything better. And so here's a demo. We're basically now using what I think probably about 80+% of the FPGA, so that's pretty good. Sure, we could fit more cores if I had more time. And let's run it. So basically now we're going to synthesize, we're going to load onto the FPGA. And we've sped this up a bit because it is quite a big FPGA, so it takes a bit longer to run. And then we'll flip over to the console and see our Hello World application. Oh, I forgot the locking. So I've got more work to be done. But it was 40 real cores running real instructions on this one FPGA. So that's where we are today. That was pretty cool. This is just a first step. As I said, this is just a proof of concept. This is just something we often played with. And we're really hoping to see more effort from the community, some collaboration around this. It's been a lot of fun. We've had a lot of fun on it in the last couple of months. We've got a lot more to add. So at the moment, we're just adding supervisor state. And so if we add a patch that Michael Newling worked on, it took him an afternoon to kind of add enough that we think will run some of the IoT OSs, so we could run one of those. A little bit more work, we should be able to get enough supervisor state to get Linux going. That should be good. And eventually, I'd love to see other people implement these cores. Let's see more of them on GitHub, maybe a Verilog implementation. Who knows? I would like to point out later on today, we have a BOF around all the open announcements that Ken made this morning. That's in the Harbour Ballroom at H at 11:20, so come along if you're interested in that. At that point, I'd like to hand over to Joe Dallaire, who's been a great support from us from Xilinx, to talk a bit more about the Alveo and OpenPOWER and everything around that. Thanks, Joe.
Thank you. Thanks, Anton. So a little gratuitous product placement here for Xilinx and Alveo. We are pleased to be working with pleased to be working with IBM and the OpenPOWER community on the Power ISA and the porting example that Anton worked on to give this product to the marketplace. One other thing I wanted to talk about is, coming from the FPGA industry, I've been in there for 20 years. His story really resonated to me with this project on microwatt. So from the Xilinx point of view, he's a distinguished engineer in software engineering. He comes from a software background, has never used FPGA, is not a hardware guy. In a short amount of time, he took our hardware, was able to port his design, create it in a very quick manner. This is really exciting for us because at Xilinx, this is our ultimate goal, is to have our products used by software engineers in the software ecosystem so they can harness the acceleration advantage of FPGAs. And so I want to commend Anton for kickstarting that. Putting this on the GitHub, Anton is seeding the ecosystem with this Power ISA soft core, and we believe that the community can take that and evolve it and drive the OpenPOWER and the open community with this solution. And hopefully we can add a hardware divide onto that Power ISA solution because FPGAs are really good at that. At Xilinx, we've been collaborating with IBM for a while, and we are going to continue to collaborate with them on data center solutions across all the verticals of data center, including compute, storage, and networking. And we look forward to collaborating more on creating solutions with Alveo that can be deployed in any server. So I want to thank IBM and Anton for this effort, and we look forward to continued innovation together using Xilinx solutions, Alveo, and FPGAs. So thank you.
Please welcome to the stage Michael Cunningham.
Clicker. The ubiquitous clicker was missing. Good morning, everyone. It's great to be here. I was asked to share some of my experiences and observations about open collaboration, and I'm looking forward to do that. But first, let me tell you all that I am excited to be here at an epicenter of free and open source hardware. I'm excited to be here because, as Aaron well demonstrated, you all are at a cutting edge of open collaboration. Kind of things have been sorted out, as Aaron pointed out, in free and open source software, free and open source hardware. We're still working things out, and to be here on a day when there are some really important announcements regarding technology on the processor, on I/O, and on memory, but from my perspective, really interesting announcements regarding governance. Governance is really very important to make it all work, to make it a place that's safe to come out and play. But a bit about me. First of all, I was trained in mathematics. I was an engineer a million years ago doing radar and satellite communications engineering. And then about 30 years ago, I went to the dark side and became a lawyer. I began to sprout little red horns at that time, as you would expect. And to the extent that I did anything that had socially redeeming value, probably didn't, I'm a lawyer after all, it was because of that logo in the lower right-hand corner, Red Hat. So for the past 15 years, going on 16 years, I've been the general counsel of Red Hat. And I've had from that perch the chance to observe a lot about the power of open collaboration. So let me offer you just a couple of observations about that. First of all, I've seen Red Hat go from the bad girls and bad boys who are renegades, trying to get a seat at the table, trying to be relevant, trying to talk to enterprises, to becoming, in fact, an infrastructure software supplier to the established world, whether that's the New York Stock Exchange, the Chicago Mercantile Exchange, the White House, et cetera. So in a very short period of time, going from this sort of rebel mindset to actually a provider. I've also seen us go from a company that was a mom and pop shop, kind of a local dry cleaner, to a company that was an S&P 500 New York Stock Exchange traded company. So we arrived. We thought we had become a big fish. And in fact, we had become a big fish in the ocean in our mind, but of course there are whales in the ocean, big majestic creatures that occasionally swim by you. And recently we encountered a large blue whale who asked if we were interested in being part of their enterprise. So that was pretty exciting stuff. More importantly, I have seen incredible value chains created. These are value for customers, value for employees, value for the entirety of the ecosystem. And from my time at Red Hat, I think we were just under $200 million in revenue, just one example of it. And by the time we were acquired by the large blue mammal, we were just under $4 billion in revenue. And it turns out that the mammal had, some gold in its belly from cleaning up treasure at the bottom of the ocean and other great places, and coughed up a little bit for us as well. So value creation was there, but that's not as important as why was Red Hat rewarded. Obviously, it wasn't rewarded in slide presentation or creation, but we'll pass over that for the moment. It was right when we did the rehearsal, so it's one of those gremlins of technology that'll bite you. We were rewarded quite simply because we were able to liberate innovation more quickly. That's it. If you reduce it down to its essence, that was it. And it wasn't innovation that we did. Yes, we are a large contributor to Linux. We are by no means a majority contributor. We're by no means even a dominant contributor. We have a swath of stuff that we do. We help liberate innovation by helping to foster an ecosystem with many other people, and then making that consumable to a variety of users. So with that as a background of some of my experiences, let me offer some observations on open collaboration. I'm going to do this through a series of aphorisms that were generated from my head of government affairs. He's a North Carolinian who was the youngest elected member of the North Carolina Assembly many, many years ago. And one day, he was talking to me, and he was talking in a southern accent, which I'm not going to do very well. And he goes, Mike, when I'm in the halls of Congress and I have to explain what open source is to maybe a senator or a congressman, and the whole time I have is to ride up in an elevator, I have to find a way to do it, and I found it. And, let's see if we can get it to work. And this is his aphorism. He says, Mike, I got to tell you, nobody's as smart as everybody. So if you take the collective wisdom and the collective creativity of a large body of people, it by definition has to be better and more powerful than a single individual. Of course, that whole notion of we're all Einsteins and they're going to come up with E equals MC squared is, There's a couple of Einsteins out there, and thank goodness we'll have them. But most of us make incremental improvements, and those incremental improvements gets assembled by different and other people. So this idea that nobody's as smart as everybody. Another thing that's true is that nobody's as fast as everybody. When you get everybody moving, you got a network of people that are co-inventing there, converging, diverging, going together. So if speed of innovation is quickly, nobody's as good as everybody doing it together. This is a really important one. Gee, I never saw it that way. He only came up with the first one, but I'll continue with the Southern accent because it's sort of my attempt at one and probably offend some Southerners in the audience, but that's not my intent. This really goes to the diversity of the innovation pool. We absolutely want gender diversity and national diversity and, you know, all sorts of other components, but we want diversity of roles, of plays, and things that people do in the community, and in particular, the user community. You know, there's a corollary to this I call the Satchmo corollary, which is nobody knows the trouble I've seen. So if I'm a producer of technology, I will not know intimately the problem that the user is experiencing as well as the user. I may not know about other problems that the user is experiencing, which I haven't identified, and I sure as heck won't know whether the solution is elegant and beautiful for solving their problem coming from their perspective. So the inclusion of users in the innovation community is huge. Red Hat never produced the Apple Newton. We never could have produced the Apple Newton. Perhaps an innovative product, but well before its time because no user was asking for it. When you get into open collaboration and have your users, you have relevance. The users help make sure everything you're doing is relevant. It's very, very powerful. It's cost effective, you know. If you don't have everybody on your P&L, you're going to produce something. So somebody else's somebody is cheaper than your somebody. Another great effect from open collaboration. This is obviously didn't come from my Southern. This came from Eric Raymond, which is a paraphrase of many eyes make all bugs shallow. At a time of specter and heartbleed and the considerations of all of society about information security, the opportunity to collaborate in an open way about security is extraordinarily powerful. Extraordinarily powerful. Nobody trusts a closed environment where you can't look in. Where you can look in, you can help identify the problems, and as importantly, you can help remedy the security problems very, very quickly. As some of you are aware, some of the Heartbleed and Spectre problems were actually compensated for in software after they were discovered. Last and perhaps the most important is I like playing here because it's fun and safe. So you need an ecosystem that makes people want to come out and play. The minimum is that it seems fair, you have good governance, and that there aren't any trapdoors, like an IP that if I use my effort and energy to participate is going to come and hang me or leave me in some position of harm with the organization of it. That's the base minimum. When you're really successful and you create an environment then that is fun to come and play, because cool people are coming to play and do exciting things, you unleash a whole other wave. That's engagement and passion. This is just a brief story of engagement and passion. At Red Hat, I have, you know, a significant number of the most experienced open source lawyers in the world. One of them, responsible for writing large portions of the GPL v3, came to me and said he wanted to go to a conference. The conference was in Europe. I said, you know, X, we have to rotate this around and we're going to let Y go. And he said, Mike, you don't understand. Open source is my life and I'm going irrespective of whether you pay for me. Whoa, we'll pay for you. Please go. But that passion, that really connecting into things that people care about, that they want to participate in, really opens up incredible stuff. And so when you take all that stuff, you could have a open office pie chart on the left, which somebody's going to get a bigger slice, and it's good, and the person who's got the green slice is happier. But when you add the open collaboration force multipliers, which I just went through, which are creativity and wisdom, speed, much greater relevance in all likelihood if you have a diverse community, cost, security improvements, and passion and engagement, the open office pie chart pie becomes, in fact, a cherry pie, and everyone's pieces are much bigger and much more exciting. Let me leave you with just one final thought. Innovation is something you should leave and feel really good about. Innovation is one of the few things in the world that takes 1 + 1 and makes it 2.7. Innovation is therefore among the most likely things to lift the lot of humanity all over the world. Can be misused for sure, but it is more likely to do that. And if you are liberating more innovation in the world, chances are you're going to be lifting the lot of humanity while doing your job, while doing interesting technology, while creating a new movement in free and open source hardware. Thanks so much.
Please welcome to the stage our panel moderator, Peter Rutan, Research Director at IDC's Infrastructure Systems, Platforms, and Technologies Group.
Can everybody hear me? Yes. Okay. Standing here talking. I am actually going to be inviting 5 distinguished gentlemen to the podium, and we're going to ask them some questions about today's announcement, what they think, and have some discussion too amongst ourselves. So with that, if all the panelists can come join me up here, that'd be great. Oh, I think I'm supposed to sit here. So from left to right with Derek Chow, we have Timothy Pearson, Alan Clark, and Steve. Your last name escapes me. Thanks. And on the left is Bobby. You guys want to introduce yourselves?
Certainly. My name is Bapi Vinakota. I'm with a company called Netrino, and I also run the Open Domain-Specific Architecture project for the Open Compute project.
All right, my name's Derek Chu. I'm an architect in Microsoft Azure and a research scientist at UT.
Timothy Pearson with CTO Raptor Computing Systems.
Good morning. I'm Alan Clark. I work for SUSE, who delivers enterprise Linux software on many different architectures. We build software from the edge to the core to the cloud. And one of the reasons I'm here, I know I'm new to this audience, but believe it or not, I actually was heavily involved with Power back in the predecessor's days, and totally loved these announcements today, by the way. It's awesome.
My name is Steve Aber. I'm the co-founder and CEO of Nimbix, which is a cloud computing company focused in high performance and accelerated computing space.
All right, excellent. So today is about open source hardware, but I thought it might be interesting to talk about open source a little bit, sort of how did open source start, and really how important has open source been? And let's start first with software. And I'm actually very interested in hearing from each of you, what was kind of the seminal moment for you with regard to open software? You want to start, Eric? Or?
Sure.
Okay.
I can start. Well, I think my seminal moment when I was a grad student downloading Linux for the first time, I think it fit on 6 3.5-inch floppy drives. I loaded it up and I'm like, wow, this is really much worse than the SunOS Solaris AIX that I was using. So, but it very clearly changed very quickly.
Yeah. That's cool.
So for me, it was a long time ago, actually, but I was tasked, and I was with a proprietary company, and I was tasked with developing an SDK. And an SDK isn't something that you go out and sell and make tons of money on, right? And I looked and I said, well, it's already out there. There's stuff available. Why don't we just use that? And the company had never done open source prior to that. They didn't understand it. They didn't understand the governance that Mr. Cunningham talked about, right? So there was a lot of education there, but it was that moment for me that once we joined and participated, I went, aha, we can move fast, we can move rapidly, we can innovate, we can collaborate. I don't have to build it all myself. So I delivered something very quickly to the market, a solution that was widely adopted, was a de facto standard. Just everything outweighed my doing that all with a team of engineers by ourselves, for ourselves.
Mm-hmm. From my perspective, I have to go with the Linux, the experiencing Linux for the first time and actually, observing it with a little bit of skepticism, and I think, one of the talks earlier, talking about some of the risks and rewards associated with it. But I think that, as someone who had a background in electrical engineering and then, seeing it happen in software, and now this announcement from today is pretty fascinating for me from a hardware perspective. But, from, again, more personally, I think I can't imagine having, even as I started Nimbix, it was so much of the beginnings were based on the availability of open source software to be able to unleash innovation much more quickly. And I would venture to say that most startups in technology today, particularly in software, are, happen only as a result of, the birth of Linux and the ability to move so quickly. So for me, that's been the big one. And I think, today what's been announced is going to be really interesting to watch. And let's, go 20 years forward and look back on this moment is really going to be interesting.
So from my perspective, I'd echo the same thing, that first experience with open source was probably in the early Red Hat days, and it really left a lot to be desired at that point compared to competing solutions. But what really started to push myself and eventually the Raptor companies over to open source was that over time, that ability to actually dig in, to change things, to mold it into what your company needs, to remove things that you don't want in the software, that becomes vital. And then over the years, especially in the 2000s, and 2010s here, it's become even more so, where the only way you can innovate is by actually having that base to build on. If you had to do everything de novo, you're going to run into so many problems, so much time spent, and it's impractical. This allows us to build on everyone else's work. You contribute the work back, and essentially everyone can find something that they're a niche for themselves or the companies, and basically offer that many more solutions than would ever otherwise be possible.
My personal favorite is Python.
I'm sorry?
Is Python. I'm a pretty incompetent developer, so Python allows you to.
Yeah.
So I think something that makes other people productive more easily, where they can focus on. It's kind of underappreciated in my mind. So any kind of open source hardware that reduces the tax of building, in my mind, is something that's going to be interesting. And I think today's announcement kind of plays into that.
Right. So. And actually, since I'm an analyst, I'll throw a data point out there. Open source has grown to a point that by 2022, we expect that 50% of all the AI hardware in the world will be running open source software, not commercial AI software. And that, I think, it says something, right, about what's going on. Let's switch to open source hardware. How important is open source hardware in general for the sort of the ecosystem, the tech industry as a whole? Who wants to go first?
I'll go ahead.
Okay.
So from our perspective, what we've observed for a long time is that there has been a trend, obviously, for faster and faster chips, but it's also been kind of consolidated. When you really look at things, you have a tremendous amount of lock-in to essentially one or two vendors. For the most part, it's two vendors. And this whole idea of whether or not those two vendors really have your company's interests in mind or not, For the most part, they don't care. They can't care at the scale they're at. They have to produce a single chip that's going to work across essentially every single market segment, roughly. I mean, obviously there's some variations. It's the same basic design. And really, we're at a point here where that sort of one-size-fits-all mentality is really starting to break down. You're getting to the point where you have various companies that have vastly different requirements, and even in the best case, there's almost no way that a single core design, a single chip design is actually going to fit all of those requirements. So where we're at is if there's a single ISA that is only able to be manufactured, say, by a couple of vendors, you're at the point where you have massive software inertia that can't be overcome. Even if you came out with hardware, could develop the hardware on your own, you're not able to actually manufacture that. You can't fill your own need. So, for instance, the announcement today is absolutely vital for companies that have requirements that the larger vendors simply can't meet. It removes permanently the whole problem of the software inertia, locking you into a specific core that may not actually, from a hardware perspective, do what you want, or may do things, more importantly, that you don't want. So from this point on, we have the potential to permanently remove the software inertia concerns and to essentially allow diversification in hardware for the first time.
Al?
So that's great. You're exactly right. I'd add two things. One is supportability and reliability, right? As was mentioned earlier, black boxes are hard to support. And one of the reasons the company I work for is a full open source company is we want to be able to support our customers. They want to know what they're running, right? They want to understand, they want to be able to look at it. They may not want to change it, but they want to understand what's running in their environment. And so having open hardware, it just continues that trust building with our customers, right? Enables us to support them. We're not going to change the hardware, but we want to work with those that do and make sure that that our solutions and the solutions within the community are running in an optimal state, right? So we get that diversification, but it also opens it up and enables us to support that diversification and give those customers the reliability that they're looking for.
So I would say a couple of things that come to mind, from my perspective with open hardware. First, I think Anton's talk got me really excited. I want to go after this and to the Nimbix Cloud, spin up an Alveo and download that microwatt PowerPC. I remember it from my days at Altera, when we talked about, getting IP blocks and processors, embedded in the FPGA. There was always a blocker on, is that IP available, or would the processor fit? And there was stuff you had to keep sacrificing in order to get these types of things embedded. And so to have the first POC, it wasn't even trying to squeeze it on. It literally barely took up any space. That was fantastic. So I'm super excited about that and what that means. And we want to go back and have our guys start. And all of you are invited. We can spin up some Alveos and start downloading some hardware. Is pretty exciting. I think the second thing that I take away it really struck me as Ken was talking this morning in his announcement is the whole notion of open governance to determine kind of how the hardware is propagated. And I think that's a really, I hadn't thought about it. You think of sort of, more of the freewheeling rebel, ISIS floating around and people, hacking on it. But the open governance is a really important piece for I think what was just said about building trust, but allowing the ecosystem to showcase the demands, of the users for what the hardware needs to do. And then you can go off and build those sort of the world's best processors. So very, very exciting from my perspective.
Yes, I agree with everything you guys all said. This is super exciting. I think that but this is really a very, very first step. I mean, I used to be a co-PI of there was a project called RAMP, Research Accelerator for Multiprocessors. What we tried to do is we tried to implement large-scale multiprocessor systems in FPGAs. And in fact, we went to IBM and said, will you give us the source code for the PowerPC 405? And they'd like, no, right, effectively. fundamentally, IBM and many other companies, IBM was not the only one, basically saw their, this hardware as their secret sauce. But as companies have changed and are really making their money in other ways, I think kind of providing the very high quality industrial grade hardware, RTL and all of the tooling and other components that are necessary will uplift the entire industry and allow us to make much more progress. The way software is done, open source software is done.
Right.
So the interesting thing about open source software in my mind is that 2 or 3 people can start and build a viable product by reusing a lot of open source software with very little labor. And somehow open source hardware has to get to that point where you don't need this massive investment to make a new product from open source hardware.
Yeah.
So somehow the software guys have figured out the consumption model for the open source product that 3 people can do Instagram on a weekend. And but there's still a huge budget when you do hardware. Yeah. And so if you can change the consumption model with open source, and then iterate on improving the product once it takes off, that's and I'm assuming it's going to be different from hardware versus software.
And we've seen a lot of new hardware initiatives, right, recently.
There's a huge number in the past year.
And so do you think that with open source hardware it will be easier than what these sort of startups have to go through?
Well, that's I think one of the interesting things is because hardware engineers have to look so deep into the future, they're typically much more unwilling to make performance compromises and area and power compromises. Yeah. And so if you don't have to make a big bet 18 to 24 months into the future, but you can iterate on your bet very rapidly, they'll be more willing to accept compromises. Yeah. So if the consumption model is I give you a chiplet or I give you a verified hard macro on a particular process node or something like that, it may not be optimal for your application, but if the cost of changing your mind is not too huge, you'd be willing to accept that. And I think that the big difference between hardware and software is the depth into the future into which you make your bets.
Yeah. So let's talk a little bit about specifically today's announcement. And I'm curious how each of you respond to it from the perspective of the business that you run or work at. What does it mean for your business, for your products, for what you're trying to do? And talk a little bit about how you think, does it allow you to diversify, to differentiate? Does it make things simpler, more complex? A couple of those things, if you could address those. You want to start, Steve?
Sure. I think my reaction, there's certainly just taking it all in and processing it. And from a cloud company perspective who invests and scales infrastructure, the immediate one, and when we do both Power and x86, and one concern I have is a point that Erin made regarding being careful not to go back into silos. And sometimes you have open source movements that compete with other open source movements. And so you can see that there's risks of the open hardware initiatives, sort of clashing with other, hardware approaches. So I think that's something that, we're going to have to see how things start to play out. But I think philosophically, highly energized because it is the path forward. I think that with Moore's law, coming to an end, innovation in silicon, as opposed to sort of running down the path of shrinking transistors, it's now more about opening up how do we configure those transistors in unique and optimal ways to solve our problems efficiently and quickly. And so I think from a ecosystem standpoint, that's something we are very much wanting to foster and continue to drive. From a business perspective, it's always how is that all going to start to shake out? So I think we're going to be along for the ride and be a part of that ecosystem so we can help steer it and participate with the ecosystem. Mm-hmm.
Going down the row? Okay.
Yeah.
So I guess from our perspective, you need to understand we support a wide range of hardware platforms, right? From the x86s to the mainframes to the powers to ARM to you name it, we're probably there. So I'm very excited about this one, as I mentioned before, is the supportability. perspective. But two, as I also mentioned earlier, we're supporting and building software all the way from the edge to the cloud to the core, right? So all these different environments. And our customers pick the hardware they pick the hardware because it solves a problem, right? Be it large cache, multi-threading, whatever. They're basically looking to solve a problem, and they want to do it, the least expensive way and get the most for their buck, right? Fastest performance type of stuff. And power, the power consumption models, all those things come into play. So I'm excited about this because to me it means we're going to be able to get a diversity of workloads running on these chipsets in different hardware environments, different software environments. And so I'm excited about the diversification, the potential diversification use of this power in different environments, and our being able to support that.
So from our perspective, a little bit of background about Raptor, many of you already know. We actually selected OpenPOWER several years back, largely because of our focus on owner control and security. Our philosophy is that the owner of the computing hardware should always have full control of it. It should only answer to them if they purchase it. Really what this announcement does for us is it allows us to guarantee going forward, barring some major shift in the industry, that we will always be able to do that. Even if we have to manufacture custom silicon, we will always be able to offer that. And up until today, that was not always a guarantee. We do what we can, but this announcement guarantees going forward that they'll always be possible. It also allows us to greatly diversify. I mean, everyone who's used one of our existing machines, right, which are now OpenISA machines, knows how large that Power 9 device actually is. It's a server chip. It fits in desktops barely. This announcement finally opens the door to, hey, maybe power can actually go down. Maybe we can replace the ARM core in our BMC with a power core. Things that we've been working on for a long time suddenly become possible and viable for the first time. This is great.
Yeah, you guys have been on this journey with OpenPOWER for quite some time, right? And so this must be sort of a seminal moment for you too, as Raptor.
Yes, it is. We've really been behind the scenes working with the OpenPOWER Foundation and to some extent with IBM, obviously, to try to really kickstart this and try to make this happen. And it's amazing to have watched it actually organically grow, within IBM, within the foundation, and finally take flight, here today. And like I said, it's something that we can finally get rid of that lock-in for software side, and we can finally really see the diversification on the hardware side.
I'm going to sound like a broken record, but the intriguing thing about the OpenPOWER thing is it's kind of releasing the ISA after a whole bunch of applications have been baked in and a whole ecosystem has been baked in. And so the other parallel effort is the ISA got released, and then you're trying to figure out what to do with it. And so if you can make it easy to consume applications, not the ISA, that you have you have the accelerator, and somebody can come along and leverage 80% of the open ecosystem to build their unique accelerator really quickly. So there's an emphasis on consuming and developing an application as opposed to just the ISA. I think that would be pretty exciting. It's a pretty unique role available to OpenPOWER and OpenPOWER ISA.
So is that how you're seeing sort of leveraging this within Netromic?
The potential is in the open domain specific architecture. We're trying to, the group as a whole is trying to build an open interface between chiplets, and where you can assemble instead of building a monolithic die, that you can assemble a product as a collection of die. And we still have the group has to settle on a logical interface between chiplets and how these chiplets work together as single die. Now, if something like an ecosystem exists where you've got an ISA and the consumption model of how accelerators interact with the ISA becomes very interesting.
So speak from an academic, wearing my academic hat. I think this is fantastic. I think this could really enable a lot of research, which frankly is kind of stalled because we haven't had access to the appropriate ISAs and actually the good implementations of those ISAs. So if IBM and other companies continue to push out, I love your little core there, but if we could actually look at some of the real implementations along with the ecosystem and allow us to modify them, and if they could run on an FPGA, this would be fantastic. I think it would really enable a lot more research.
What is the impact on sort of competition in the industry? Will we see increased competition because of a phenomenon like this, or more sort of collaboration and competition? Anybody have any points of view on that?
Yeah,
go for it.
Yeah, I do. So from my perspective, it's really going to depend on where we go from here in terms of actually, like you were saying with hardware design. What is actually available? If we can rapidly develop essentially a set of cores, definitely in collaboration with an IBM and other players here, there's a potential for the Power ISA to actually become the dominant ISA, in my opinion. That being said, the competition is actually going to get more fierce from here on the hardware side. Just because you have a common ISA, which basically allows that software to run on any hardware, does not mean you're going to have less competition. You're going to have more. You're going to have hardware vendors that say they're going to be able to, and probably rightfully so, accelerate certain workloads far beyond others. You're going to see specialization. So it's not going to be competition like we know it today, where you have basically 2 or 3 major players all trying to knock each other out of the race. It's going to be more of, for a specific workload, you're going to select one vendor. For another workload, you might select another vendor. For general purpose computing, you might select even yet another vendor, that sort of thing. And we're already seeing this occur with accelerators, right? The only vendor that is really saying, hey, you can do all your workloads would be the FPGA vendors. Everyone else is saying, hey, our accelerator can do this workload, our accelerator can do that workload, and you select whichever one you need. Fundamentally, I think we're going to see the same thing for CPUs.
Mm-hmm. Yep. Anyone else have any point of view on that? Or Steve?
Yeah, I think that ARM is an obvious one that's going to be interesting because it's based on royalties and IP licensing of their cores. So I think it's going to be disruptive from a processor standpoint. It'll be interesting to see what happens on the x86 side longer term. As this continues to gain momentum. And I think, though, what's interesting is having even the move of hardware being opened, what that will do with the software developer ecosystem, knowing that there's an open hardware. And that could have a stronger gravitational pull than we might predict. And I think that's going to be interesting to observe over time as well.
My hope is this will encourage other companies to open. It may be hard for ARM and Intel to do that because they have their dominant positions in the marketplace. But if there's momentum behind this, which I think really requires releasing more and more into the open platform, and this really has to probably be driven by IBM. That at some point, there may be this tipping where people like, well, I'll just use this; it's good enough, and I can modify it the way I want it to, the way I want to. So.
In the chiplet world, somebody brought up this question about security. How do I know that if I buy a third-party chiplet, it's not a malicious chiplet, or it's somehow going to impact me in some fashion? And if you're building a CPU chiplet, you might come to the point where somebody says it has to be an open ISA so that I know what's baked in, I know what the expected behavior is, or an open implementation, so I have some full insight into what it's supposed to do. And so the one interesting sort of leg up seems to be that open implementations and open ISAs may actually be preferred, just like Linux seems to be the sort of OS of choice for hardened systems.
Yep.
That you might have a similar advantage in the hardware world.
Yep.
A few other just streaming thoughts here on that, and Derek may have some perspective with Microsoft. But what the hyperscalers choose to do with this will be interesting, and not just the U.S. hyperscalers. Knowing that there's already work going on to create their own silicon, to be able to unlock from sort of the traditional vendors, potentially completely, is interesting to see what dynamics that creates in the market. I think also from the system OEMs that again have followed this cycle for decades, of sort of the way technology hardware is released, developed, and so forth. So I think that again, this is feels very disruptive, and I think the reactions that people experience are going to be everything from dismissive, like no big deal, business as usual, but then allowing that small community to keep driving something that potentially gets quite large. But I think that the hyperscaler reaction to it again, and you're already seeing that tug with Epic, and AMD making inroads, ARM, having some footprint inside of AWS, and so this could be a game changer from that perspective.
So Erin was earlier saying, historic day. Do you guys agree today?
I definitely think it is. Like I said, I was involved with a predecessor to this organization, and I'm excited about this because we're addressing the things that just wasn't the right time for them to happen back then, but they were also barriers, and so I'm seeing those barriers fall, and that's why I'm excited about today's announcements, is because I think it's going to definitely accelerate this environment.
Anyone else? I think we could probably allow some questions at this point from the audience if there is an interest in posing a question. I'm not sure if there are microphones going around that we could use,
we'll
but
give them
the
ours.
room is probably small enough. I guess we have some microphones here. Anyone have a question for any of the panelists? Over there.
Earlier you said that in a certain amount of time, roughly 50% of all the software that's used is going to be open source. I wonder how the gentleman that from UT Austin and Microsoft Azure, what you think about that. How's that going to affect Azure and the whole
Well, Azure at this point, I don't know if we've tipped over to 50% Linux or not, but we're if we haven't, it's very close. And so we're already seeing this is the way the world's going. And it turns out, Microsoft has bought GitHub. We probably check in more into Linux than anyone else. At least from what Microsoft is doing, we're very supportive of the open source, and we think that's that at least in my opinion of what Microsoft sees, that's where things are going.
Other questions?
Just a comment about the ecosystem being so critically important. Early days, and there were concerns about the instruments of control of intellectual property, and organizations like OIN popped up that made it safe for people to come out and play. The move to OpenPOWER under the Linux Foundation, the majority vote in the working group, and the patent licensing that was described, only touched on, those are absolutely critical pieces to permit the innovation to continue. So if you're thinking about it, we tend to think about technology, we tend to think about software. The environment is very, very important to focus on.
Mm-hmm. Yeah. I know academics who basically ARM went and very politely said, stop working on building an ARM ISA RTL or simulator or whatever. This is something which has been, I think has really kind of stopped or slowed down research, and that should be done. I think the fact that this is open from a legal perspective is critically important. I think is going to be a standard. It's going to be something that I think other people should be following.
The only other comment I make, which will appear self-serving, is IBM was not exaggerating when they said they were in the forefront of open. Open Invention Network was I was there when it was created. Was wholly created within the four walls of IBM Corporation, and so their ability to be an effective steward on some of those issues has certainly been demonstrated in free and open source software.
Thanks.
Yeah, totally. So one of the big things, hardware companies are, sort of open source software seems to have settled on a free model in terms of, and the big open question is, given the big investment in developing and implementing and validating hardware, whether free is a viable model or there has to be some other licensing model, which still enables fast consumption, but that seems to be a huge difference between hardware and software. That universally hardware companies are not comfortable with free licensing. As you know, we've put in a lot of person years worth of labor into this, into validating analog circuitry on a new process node, or debugging and verification, and free is a loaded word. So that's a big, I don't know how it gets resolved, but that's a big issue really that keeps hitting us in our project.
I mean, but software developers have to do all that too, right? And so I know that hardware has its own set of challenges, but yeah, if you look at how much work the software developers do to develop and verify and deploy and all that, that's...
I think there's a feeling that software people can change their minds, and the hardware cycle is so extended that the penalty is severe. And that I don't know what the answer to that is, but that's a major challenge.
That's a valid point. Yeah.
Fundamentally, I'm not sure where opening the ISA is really going to open those kind of challenges. I mean, you're going to have people collaborating, I would expect, largely on FPGA type implementations, only those that actually pass, and it's still going to come down to business concerns, only those that you can demonstrate to the appropriate business leaders, appropriate people in that space are actually going to make their way to real silicon, at least in the commercial sphere. Academic sphere may be a little bit different, but fundamentally we do have a prototyping tool. You could think of it maybe more in the early days of, I don't know, mini computer revolution, that sort of thing, where yes, you needed, for a large project, to actually commit serious resources, you needed to have time on, for instance, a mainframe or a large machine. Yes, you could do your initial work on a much, much smaller, much more limited box, but if you were actually going to commit and go forward with the project, you went up, you paid the money for the resources to actually create the product. And I guess for silicon, I guess how is that a whole lot different? At this point in time, we have a ton of old process nodes, we have a ton of information. What we currently lack, and this was brought up before, is the actual open tooling to take something from HDL or even RTL and actually convert it into anything that can be made at any of those fabs. And that's something that's going to need to see serious work before we can even think about the commercial considerations of really open silicon. This is a first step. This allows companies that have the resources and want to commit to design, create, manufacture their own silicon. It does not solve those underlying problems yet. And that's where the community as a whole, I think, still needs to say, and this is where actually we're going to need foundries really to kind of commit to this whole concept, is that how do I put it, the older process node information is not proprietary, or that it can be brought in a standard interchange format into open tooling, where we can actually do the design work, actually do the validation work, do the simulation work, and prove that something's going to work before you actually commit to manufacture.
I just said that sounds like a lot of fun, actually. It does. It just makes you want to get in there.
Any other questions? Up there?
Kind of a vision statement or a vision question, crystal ball question. From this announcement, what do you think you see happening in the industry 5 years out as a result of all this openness? Crystal ball moment.
Crystal ball question. Who wants to take it?
I think that's Garrett, isn't it? Wow, it's nice to see you, dude. So, to me, it's part of a trend, right? So you and I have been in this business for a long time, and we talked about the early days of Linux and the years it took for acceptance of Linux into the enterprise, right? And then all these other projects. I think it was Ken that showed the slide of IBM's contributions to the different projects over the years. But what you're seeing is the speed of adoption, right? It didn't take the 25 years for Linux. It didn't take Linux 25 years, but we can argue when it tipped the scales into the enterprise, right? But you can see the impact. And the impact is, my point is, it takes much less time nowadays for that impact to be real and to be adopted by not just fringe and not just early adopters, but to be hardcore enterprises, right? You can't fly in an airplane today without it being run on Linux. You can't, those planes are directed in the skies by Linux. Your phones, everything we do is touched by open source. And the speed of adoption is totally accelerated. So 5 years from now, I think we're going to be blown away, simply because the adoption curve is so fast nowadays. And it's not just open source. My point is the adoption of collaboration through open environments, through open governance, and so forth, is changing our world, right? So, like I said a minute ago, it's going to be fun to dabble in the silicon, and I think it's going to happen. I think we're going to be surprised at what's going to happen in the next 5 years.
So I'll go a step further, and maybe this isn't quite a 5-year vision, it might be a little further out. But I was thinking about it as we were talking about, the RTL for these, the instruction set architecture. That becomes data available when you bring that into the ecosystem, and the number of people, the number of implementations, or the ability to scale that horizontally becomes data. So then you imagine that being used with deep learning, and AI, and you start to think about what can happen now when we take the machines themselves and allow machines to take that, now that it's open, it's all data that can be used and fed into these neural networks and allow machines to actually design themselves, which I think is really interesting.
You want to do a 5-year prognosis? Okay.
My narrow prediction is, I think there's the one interesting thing is now you can do a new many-core architecture. You're kind of like limited if you're going many-core. Right now it's either ARM or RISC-V. This is a really interesting thing where you can see 128, 256, or the microwatt or some cousin of the microwatt. And because then you have the academic innovation and interconnect between many-core. So what I'm thinking is in 5 years, there'll be at least 1 or 2 many-core PowerPC architectures. And that might actually be specifically interesting to our company as a use case. I think there's a new entrant of the many-core.
So I would say that it's kind of hard to look that far in the future in some ways, but one of the first things that this is going to do, the most obvious low-hanging fruit, is it's going to enable the ability for people to actually trust their computers again. If you purchase an open ISA chip, the first step, obviously, at least where we are right now, is that you can go down to the firmware, you can go down to the ISA, you can verify everything, you can know what's actually happening with that device. I think that over the years, and this is where I say I'm a little uncomfortable on timing, because I know, as from a hardware background, how long this can actually take. But over time, what we'll see is that you'll be able to peer further and further down into that stack, and you'll be able to know more and more that what you have in front of you is actually doing what it's supposed to do. It's not working against your interests. It's not going behind your back. So to a certain extent, in an era where people are giving up Google, they are leaving their cell phones outside somewhere or whatever when they're doing sensitive work. When you literally go into a company, it says no cell phones. No, they're literally technologies are being banned because of security concerns. All of a sudden, we can actually see the technology go back into those environments and actually assist rather than have to be eschewed based on these concerns. So it's a really big deal there. Fundamentally, though, going forward too, I suspect what we're going to see is some degree of consolidation in the software space. Right now, just right off the bat, right now, even in the commercial software space, we see vendors having to support x86, ARM, Power, even to some extent RISC-V at this point is really coming up too. And bluntly, from a software QA perspective, what we're seeing right now is that that's a bad experience overall. Each one of those software packages has a dominant architecture that the developers are using, and that, for the most part, with the exception, unfortunately, rare exception of some software houses that take QA seriously, means that the development architecture is the only one that the software is properly functional on. I realize that with open source, thankfully, there's more community QA that goes into it, so that's been largely smoothed over. But especially for those vendors that are still using at least proprietary license or sort of an open source but don't touch model, that's a significant concern. It's a sort of a drain of QA. So as you go in the future, I would expect that there be some consolidation assuming that things are executed correctly, that we don't end up with every vendor having a problem kind of situation, that there be some consolidation around an ISA or a couple of ISAs so as to avoid that whole software issue. And then from that point on, like I said, I do see hardware diversification, literally accelerators and steroids, the ability for the CPU itself to be swapped out or to be modified or purchased, whatever, to meet a specific application. So very much a heterogeneous computing future, I would think.
Yeah, so for me, I'm hoping that, and it's going to be longer than 5 years, but I'm hoping that the open source, kind of hardware will look very similar to open source software, that we're going to have technologies that allow us to prototype, develop, deploy, and actually build real chips that allow, I can do it in 3 months for $10,000 instead of, what it takes, you all know very well what it takes today. And if that happens along with the continued advancements in open source software, we can actually start thinking about really open systems, which I think are, when you multiply the two together, is just really gonna revolutionize our field beyond what we've seen before.
Other questions? Yes.
I'm going to take one. So there was 2 parts of the announcement. You guys have been focusing on the ISA side of it, and I know it's a bigger hurdle. What, as far as the interconnect technologies are coming into as well, the memory interfaces, the accelerator interconnects, how might that be something that might be taken advantage of a little sooner than producing a microprocessor or an ISA chip? How could those interconnects change and ratify and quickly help innovation around system topologies?
I guess from our perspective, that's part of the announcement that I'm excited about, because as we've talked about, it builds that trust all the way down, right, the different layers. But one of the things our customers are looking for is consistency across all the different, as I mentioned, we run on all these different architectures and platforms and devices and so forth, right? But our customers are expecting consistency. And the excitement I have on this is our ability to help them achieve that consistency, right? The consistent feel, look, use, reliability, sustainability, all the abilities that you can name. But the key word there is consistency. It's going to enable us to bring and help them maintain that consistency across all their deployments, whatever architecture those will be.
I mean, to me, the interconnect's more important than the ISA, much more, right? Because for exactly the same reason, now I can plug a RISC-V with a AMD with a Intel processor and an ARM processor all in the same system and have them all use the same interconnect. That's fantastic. So.
Yeah, we had a conversation. I think the interconnect has the potential to help disaggregate inside a package and maybe make new commodity chiplets, like a memory chiplet is an obvious thing that could potentially be possible because of a disaggregated interconnect. So the ability to sort of build heterogeneous systems will be driven by the interconnect in my mind.
I deviate a little, and I'd say here that the interconnect, while important, it's a package. We can't have one without the other. You mentioned, for instance, integrating AMD chips, but the simple fact is, without you having access to AMD's technology, there is no interconnect. There is no connection.
Again, the hope will be that as people say, hey, this is a great interconnect, I'll start developing for it. Other people are like, well, I'll adapt to it, and then, hopefully it'll move in the right direction.
One can always hope, but I would just kind of mention in the industry, look for ages at AMD's HyperTransport versus I think it's Intel's QuickPath. They do the same thing. They don't talk to each other, and despite all the advantages of being able to do that, it hasn't happened. So, I think there's some sea change that would have to occur at those companies to make it happen. But the OpenISA is a good step in that direction.
So we have 1 minute left. So let's do one more question and then very quick answers. So. Okay, go ahead.
More of a practical question. I can imagine all sorts of wonderful things in crystal balls. Thank you for asking that second question. For me, looking at communities and being a part of the Linux Foundation, I think it's a wonderful start. But what do you see as the heavy lifting required in the short term it's my understanding like 90% of the open source communities fail, right? So given that, what is the heavy lifting required to actually build community? Obviously includes research communities. What would be your view in terms of success in the short term?
Who's going first? All right, Derek, you want to go first?
So for me, it's the ability to interconnect the components, right? So what winds up happening is anyone who's done RTL development knows that we tend to optimize our interfaces too heavily, so that if I try to plug one block into another block that haven't been designed together, it's probably not going to happen. So having an abstraction that allows me to, effectively do function calls like we do. I mean, there's a standard C function call. It doesn't matter which compiler produced the executable, the object file. I can go and call across between two different. One piece of C code can call a function that was developed potentially by another compiler. Until we get to the point where we can go and snap things together very quickly, I think we're going to have a hard time because people are going to be spending all their time writing gaskets between the various components.
I would build on that some, and I would say that I think one of the key things we're going to need in the relatively short term is we're going to need open FPGA tooling. Obviously, ASICs, hard silicon, there's a lot of challenges there. That's not a short term, that's a medium to long term issue. But in the interim, we need to be able to develop that technology, and for the most part, that's going to require the community to come in here and actually collaborate on and basically add that new functionality to the tooling. And that's something we can't do if we don't have open tooling available to target these FPGAs. Now, there are a few projects that are, for instance, available now, but I'll just bring up an interesting issue. For instance, the microwatt core is VHDL. Those projects accept Verilog. So there's interoperability concerns all up and down the stack, even starting at this relatively high level of software.
All right, we're out of time, and I think what was earlier said. We're 1% there. It's a lot of work still to be done, but still an exciting moment for the industry. Thank you, gentlemen, for your comments, your insights, and thank you, audience, for your questions. Great discussion. Thanks very much.
Please welcome to the stage Mindy Furman, President of OpenPOWER Foundation.
So thank you, everyone. First off, I want to ask, how many of you know how many times open was mentioned in the last 2 hours? I tried to keep track. I lost count. So that's exciting. And I'm going to keep this short, but there's two messages I want to leave the audience with here. First is I want to thank everybody for being here. The Linux Foundation and running this event, the OpenPOWER Foundation, the OpenCAPI Consortium, everybody who's here and joined, our sponsors, a lot went into make this happen, and everything that went into making the announcements happen. We're super excited about it, and that's the second thing, is speaking on behalf of the OpenPOWER Foundation. I'm so excited to be here. I hope you guys are excited, and I'm really excited to see what's coming forward and next. I was standing over there, and someone came up to me and said, "Oh, what else are you going to announce? You have another thing up your sleeve?" I said, okay. Yeah, at some point, Christmas, is over. Packages are unwrapped, we're done, but there's going to be more. And I guarantee there's going to be more packages to come, and not just from us, but from the community and from everybody involved. We're super excited, and I am so happy that the secret is out now, because keeping this secret was, you always wanted to talk about it, and we couldn't talk about it. And to be here and have it all come out and see the excitement and everybody just really talking about the industry shift and change, because that's what we want to see, and that's good for everybody. So thank you, and with that, there is morning tea, and there is a session in Harbor, I think it's H, for Birds of Feather, where we'll talk more if there's more questions. Myself and Anton and others will be there. So enjoy.